In this video, we're going to do example 5.3.1, where we're asked to find the average value of f of xy is equal to x times sine y over d, where d is the region enclosed by y equals 0, y equals x squared, and x equals 1. So let's remind ourselves that the average value, f average, is defined as 1 over the area of d times the double integral over d of f of xy dA. So what we first need to do is find d, or sketch d, find its area, and then find the integral of f of xy over that region d. So we'll start out by sketching d here. Now we have y is equal to 0, which is the x-axis. We have the parabola, y is equal to x squared. And we have the line x is equal to 1. So here's our region D. And we can describe this as a type 1 region. So 0 is less than or equal to x is less than or equal to 1. And 0 is less than or equal to y is less than or equal to x squared. So we want to find the area of that. And so the area of D is going to be the double integral over d of 1 dA. So we can write that as the integral from 0 to 1 of the integral from 0 to x squared of 1 dy dx, which is going to be the integral from 0 to 1 of, well, we have y from 0 to x squared dx, which is the integral from 0 to 1 of x squared minus 0, so I'll just write x squared dx, which antiderivative 1/3 x cubed from 0 to 1 is going to give us 1/3 minus 0, or 1/3. So there's the area. Now that is going to be our denominator over here, so now we have to do the double integral of our function over this same region. So we'll take the same bound, so the integral from 0 to 1, the integral from 0 to x squared of x times sine y dy dx. Now the inside integral is with respect to y, so I can actually bring that x just outside of that first integral. So I'm going to get the integral from 0 to 1 of x times, and now I need an antiderivative of sine, which is going to be minus cosine of y, which we are running from 0 to x squared dx. So we are going to have here the integral from 0 to 1 of x times minus cosine of x squared minus minus. Cosine of 0 is 1 dx, and we're going to have what here? If we rewrite this, the integral from 0 to 1 of x minus x times cos of x squared dx, which will split into two integrals. So the integral from 0 to 1 of x dx minus the integral from 0 to 1 of x times cos of x squared dx. The integral on the first one is simple. Yes, we do 1/2 of x squared from 0 to 1. And on the second integral, we'll do a substitution. So we'll let u be x squared, and du is 2x dx. So 1/2 du is x dx. When x is 0, we get u is x squared is 0. When x is 1, u is 1. So we're subtracting 1/2 the integral from 0 to 1 of the cosine of u du, which is, so evaluating the first one, we get 1/2 times 1 minus 0, or just 1/2, minus 1/2. Now we need an antiderivative, so integral of, or antiderivative of cos is sine of u from 0 to 1. So we're getting 1/2 minus 1/2 the sine of 1 minus the sine of 0. Sine of 0 is 0. And so we have as function value here, so 1/2 minus 1/2 the sine of 1. Now, that's the function value. We had the area up above, which was 1/3, and then we have the average value that we want. So if we have those two components, we can write f average is 1 over the area of d times the integral over d of f of x, y, dA, which is 1 over 1/3 times this 1/2 minus 1/2 the sine of 1. And if we clean that up a little bit, we are going to get 3/2 1 minus the sine of 1 as our average value. In the next video, we're going to look at the application of double integrals to volumes.